Good day, everyone. Here I am again to discuss to you principal roots and irrational numbers. That is for week 6. So we have here the learners, our learning competency rather. We have the learner describes principal roots and tells whether they are rational or irrational. And the learner determines between the what two integers the square root of a number is. So what do you need to understand here is that we're going to identify if it is rational or irrational roots. So can you tell what time is it? It is so based from the unusual wristwatch. So what can you say about it? Okay, so next we have, so based from here, as you can see, by the way, based from here, as you can see, you have square root of 1, square root of 4, square root of 9, square root of 6, this one, this one, this one, this one. Okay, what does the symbol this denote? The symbol. That symbol denotes a square root. To indicate the existence of two roots, we write the positive and negative square root symbol. To express only the principal root or the positive root only, we use square root. Then to indicate what we are looking for, the negative root, we just indicate negative of the square root of. Okay, for example, we have square root of 4. So the square root of 4, since no sign here understood that is positive, therefore we will just get the principal root. But if you have, positive 4, square root of positive 4 can be positive 2, or it can be also negative 2. So therefore, square root of 4 can be positive or negative 2. So therefore, in square root of b, the answer is always positive and negative a. If b is a perfect square number, then a is a rational number. Okay, if b is a perfect square, therefore a is a rational number. Okay, so what do you mean by perfect square? Perfect squares, the product of a rational number multiplied by itself. These are numbers that have rational numbers as square roots. The square root of a number that are not perfect square are irrational. Okay, so the square root, again, the square root of a number that are not perfect squares are irrational numbers. Okay, another we have here again, numbers that have rational numbers as square root, which is, we have here, perfect square is the product of a rational number multiplied by itself, and that number have the rational number as the square root. So if the given is a perfect square, therefore the square root is a rational number. If it is not perfect square, therefore the square root is an irrational number. Example, 1 squared is 1 times 1 is equals 1. 2 squared is 2 times 2, therefore it is 4. 3 squared is 3 times 3 equals 9. Then 4 squared is 4 times 4 equals 16. And so with this one. And this results here like 1, 4, 9, 16, 25, 36, 49, and 64, and so on. If you will continue this one, like 9 times 9, 10 times 10 rather. Therefore, The result there are examples of a perfect square number. So those are perfect square numbers. Okay. So we have here another, we have principal nth root of a number. The principal nth root of a number, of a positive number rather, is a positive nth root. For example, 6 squared is 6 times 6, which is 36. This means that the square of 6 is 36. Therefore, the square root of 36 is 6. In symbol, we have square root of 36 is equals 6. Note that when we are taking the square root of a number, it is not necessary to write the n, which is 2. It's understood that we are taking the square root of a number. Okay, so that's it. So you don't need to write the 2 here. It is always understood that it is square root. Okay. Another, we have the principal nth root of a negative number is the negative nth root of a number. Nth root if n is odd. Okay, again. The principal nth root of a negative number is the negative nth root if n is odd. Like for example, this one. If your n is odd number, okay, odd numbers are 3, 5, 7, 9, 11, 13, 15, those are odd numbers. So if your n is odd, therefore the square root or the nth root of this number, if it is negative, the nth root, okay, of that number is always negative. Negative. That is if the base is negative and the exponent, or it is raised to an odd exponent. This means that the cube of negative 4 is negative 64. Therefore, the cube root of a negative 64 is, of negative 64 rather, is negative 4. In symbol, we have cube root of negative 64 is negative 4. So note that it is only applicable if n is odd. By looking at the example, n is 3 and we know that 3 is an odd number. Okay, that is if your exponent is an odd number and your base is negative. Therefore, the answer is always negative. The square root, the cube root rather, is also negative. What if n is even and the number is negative? The principal nth root is not defined. Okay, again, you have here, if n is even and the number is negative, the principal nth root is not defined. Like for example, principal root of negative 4. The result is error. Okay, so that is not defined. So square root is not defined if the number is negative. The notation for the principal nth root of a number b is, okay, the notation for the principal root of a number b is nth root of b. Okay, that's the symbol. In the expression, n is the index, okay, we call this as your index, okay, and b is the radicand, and your b is called the radicand, and the nth root are also called radicals. Okay, the nth root is called radical symbol. We have this one. It must be somewhere here. It must be somewhere here. Okay, because index should be written in this part. Small here, like n. Okay, so make a correction. You have to put this one here, like that. Then this one is called the radicand, and the symbol is called the radical sign. Okay, so consider the following. We have 3 raised to 4 is 81. This means that 3 raised to the 4th power is 81. Therefore, the 4th root of 81 is 3. In symbol, we have 4th root of 81, and that is 3. 7 squared is 49. This means that the square of 7 is 49. Therefore, the square root of 49 is 7. In symbol, we have square root of 49 is 7. Negative 5 raised to the 3rd power. So that is equals to negative 125. This means that the cube of negative 5 is negative 125. Therefore, the cube root of negative 125 is negative 5. In symbol, we have this one. So since the index is odd number, therefore it is negative. So integers such as 1, 4, 9, 16, 25, 36, 49 are examples of perfect squares. Rational numbers such as 0.25, 36/100, and 0.01 are also perfect squares. Okay, they're also perfect square numbers. Okay, what about square root of 2, square root of 3, and square root of 7? Are they rational or irrational? If we take the principal root of 2, 3, and 7 rather, using calculator, we get this one. Okay, so we cannot tell the numbers are terminating or repeating. So since we cannot find the decimal number which when squared will give us square root of 2, square root of 3, and square root of 7 respectively, we can say that these numbers are irrational numbers. Okay, these numbers are irrational. If the principal root is irrational, you can get the estimated value of its principal root rather. Going back to the wristwatch, can you now read the time? What time is shown on the wristwatch? Okay, what time is shown in the wristwatch? Okay, we'll go back there. What time is shown? That is 10 square root of 100. That is 10 like 4. That is 10 9. 10 9 because this is 1, this is 2. That is 5 minutes. Okay, 10 minutes. So this is somewhere 9. So our time is 10:09. 10:09. Okay. So what's the time? It's okay. The hands of the watch lay at square root of 100, which is equals 10, and 1 unit before the square root of 4, which is 2. So that is the time is 10:09. So we have here activity 2. In your activity 2, activity 1 first, supply the missing value and put a check to determine whether the principal root of a number is rational or irrational. Okay, so supply first the answer here. You put the answer first, like the square root of 1 to 1, what is that? And if the root is 9, what should be here? And if the given is 0.36, what is the square root? Then you have to identify if number 1, based on the principal root, is it rational? Put a check if it is rational. Again, if it is rational, put a check, or irrational, put a check there. So only it's either of the two. So is it rational or irrational? Rational or irrational? But before you're going to say irrational or irrational, be sure that you will supply first the answers here. Okay, that's it. Next is for activity 2, we have sort the numbers into 2 groups, rational or irrational. So write the numbers in the appropriate circle. So you just put this inside the circle. If it is rational, then put it rational. If it is irrational, then put it inside the irrational circle. Okay, that is for activity 3. For activity, okay, that's for activity 3. 2 or 3. Okay, so these are the key points, principal and truth. The principal and truth of a positive number is the positive end root. The principal and truth of a given negative number is the negative end root, if n is odd. If n is even and the number is negative, the principal end root is not defined. So the notation for the principal end root of a number b is given by n root of the square root of b. In this expression, n is the index, b is the radicand, and this one is called the radical symbol. So classifying principal and root as a rational or irrational number. So to determine whether a principal root is rational or irrational number, determine if the radicand is a perfect end root of a number. If it is, then the root is rational. Otherwise, it is irrational. Okay, that's it. Okay, so for your assessment here, you will just supply the answer here. What is the square root of 45? What is the square root of 0.01? What is the square root of 1 over 36? Square root of 500? Then if the answer, or if the principal root is 12, what should be the given? If the principal root is 15, what should be the given? And then based on the answer, you have to identify if it is rational or irrational. So only one answer, whether it's either rational or irrational. So that's it. So the answer are just here. You just supply it there. So you get your answer from the box. Okay, so that's it. So here on the assessment 2, you will just encircle all the rational numbers. So just encircle. If it is rational, then encircle. That's it. For the assessment 3, Anna got lost on her way to the bookstore. Anna helped find her way, and by determining whether the principal root of each number is rational, irrational, or not defined. So just color the way they will lead her to the bookstore. So you just put if it is rational or irrational. Okay, you just color it.